Hello everyone. This session I will share with you how to solve the periodic convolution using the wrap around and the cyclic methods. Periodic convolution is used when the signal is periodic. First of all, what is periodic? Periodic is the signal can be repeated again. So periodic convolution is measured by using the average. If the P is referred to periodic, if XPN and the HPN are periodic with identical period of n, okay, if the number of periodic is known, their periodic convolution generates a convolution result, okay, called YPN. That is also periodic with the same period n. The periodic convolution or circular convolution can be denoted by YPN equal to XPN convolute with the HPN. Now let's look at the example. Find the periodic convolution of the XPN equal to 1011 and HPN 1231 with the period of n is equal to 4. So first of all, you need to know what is the starting index and the ending index. Okay, starting index, if you look at the XP here, is 0, HP also 0. And for the starting index is 0 plus 0 is equal to 0. For the ending index, for the XPN, you have 1, 2, 3. So this one we have 3, and this one also have 3. 3 plus 3 is 6. So ending index is 6. And then, so you know that the starting index is 0 until 6. That's why the n is starting from 0 until 6. And then we write the HPN is 1231 and XPN is 1011. Okay, again you multiply. So 1 times 1, you get 1. 1 times 2, you get 2. 1 times 3, you get 3. 1 times 1, you get 1. And then followed by the 0. 0 times 1, 0. So everything times 0, you go 0. Again this one. This one times with 1, you get 1. 1 times 2, you get 2. 1 times 3, you get 3. 1 times 1, again you get 1. Okay, and the last one is also here. 1 times 1, you get 1. 1 times 2, you get 2. 1 times 3, you get 3. And 1 times 1, you get 1. So the yn is you sum up everything here. So 1, this one is 2 plus 0, get 2. 3 plus 1, get 4. 1 plus 2 plus 1, you get 4. 3 plus 2, get 5. 3 plus 1, get 4. And 1 equal to 1. So your numeric sequence is like this. And then bear in mind that you have to put your indicate where is your origin. Origin is at the value of 1 here. So the answer here indicates is the same as sum by column methods. But what is the difference if you use the periodic convolution? The difference is when the question said the period of n equal to 4. Okay, so you need to wrap around. So first half of the yn, just now the answer is 1, 2, 4, 4, 5, 4, 1. Okay, so n equal to 4 means that you only have 4. And then repeat again after 4 numbers. So 1, 2, 4, 4. So you already have 4 here. And then value number 5, you got to use another row. So 5, 4, 1. Okay, and then you're not enough because you only have the 7 numbers, 7 value. But if you set the periodic n equal to 4, you're supposed to have 8 value, right? So the last one don't have the value, so you append a 0, wrap around the last 4 samples and add. So you add up 5 plus 1, 6. 4 plus 2, also 6. 1 plus 5 is 6. 0 plus 4 is 4. So this answer, we call it as a periodic convolution, YPN. So this is the final answer of the periodic convolution, in which they said that the n is equal to 4 in the question. There's an exercise here. You can do the exercise 2.5 to increase your understanding. Okay, this one is with period n equal to 3. And answer is provided. Another method of periodic convolution is the cyclic method. So in order to use the cyclic method, you shift the folded signal x minus n past the HPN. So one index at a time, and find the convolution at each index as the sum of the pointwise product of their sample, but only over one period window. Okay, value of XP and HP outside the range are generated by periodic extension. So one way to visualize the process is to line up the XK clockwise around the circle and HK counterclockwise folded. Now let's look at the example. Find the periodic convolution of the XPN 123 and HPN 102 with the period of n equal to 3 using the cyclic method. In order to solve this question, we have few steps to follow. So first of all, XPN is clockwise. And then HPN is counterclockwise. Counterclockwise, this means that it indicates that it's flipped. So it's counterclockwise. Okay. This means the clockwise and counterclockwise means that when we want to put the value of the XP and the HP in a graph, we put it clockwise or counterclockwise. Okay, later I will show you. So second step that you need to know is rotate. How many times I need to rotate, because it's cyclic methods, right? So n minus 1. The n given is 3. 3 minus 1 equal to 2. So 2 times I need to rotate. Number 3. Where is the position of the xn and xn and hn? So xpn always inside. And then HPN always outside. Okay, what's meant by this? Now, I have 2 circles. So this is the first step. Okay. Now I have the value of XP. Okay, I have the value of XP. And XP, it should be always inside. So this one is XPN. And XPN, I have the value of 1, 2, 3. Okay, 1, 2, 3. Value XPN 1, 2, 3, and is clockwise. So the value, you put it clockwise. So 1, 2, 3. So it's clockwise. Okay, clockwise is like this, clockwise. Now, how to put the HPN? HPN is always outside. Okay, And then it's counterclockwise. See that? Counterclockwise. This one, counterclockwise. Always outside. Okay, so that's why you have the HPN is always outside and the value is counterclockwise. What is the value? 102. Okay, 102. This means that I have the value of 102. So you can product the points-wise value. Product the point-wise means that you product each point. So y0, what is the y0? Y0, you have 1 times with 1. So 1 times 1 plus 2 times 2 plus 3 times 0. So what is the answer? 5. Okay. Now, number 5. So after that, you need to rotate. So you rotate the outer sequence only. But clockwise. So again, I draw the circle. Okay, so this one remain 1, 2, 3, the value remain. But the outer sequence rotate the outer sequence. So just now is, if you look at here, is 102. That is the original value. Okay. Now you rotate outer sequence clockwise. Okay. So initially the 1 is here. So initially the 1 is here. Now your 1 should be turned to here. 2 you shift to here. The 0 shift to here. Okay. So you have 1, 2, 0 here. So y1 equal to what? Y1 equal to 0 times 1 plus 2 times 1 plus 3 times 2. This one. So you get 8. Then step number 6. Rotate again the outer sequence. For second time. Clockwise. Again you draw. So inner, the value always the same. We only clockwise the outer sequence. So just now, the 1 should be moved to here, 2 move to here. So you have 1, 2, 0. So your y2 value equal to 2 times 1 plus 2 times 0 plus 3 times 1. This will contribute to 5. Finally, you write down the answer. That is 585. Alright, so this is the cyclic method for the periodic convolution. Alright, thank you for watching. And if you like my video, please like my YouTube video. Thank you.